In this video, we're going to construct a 1 minus alpha times 100% confidence interval for the difference between two population proportions when we have independent samples. So this process is going to be very much like the process we used when we constructed a confidence interval for a population proportion. The difference is going to be that we're looking at two population proportions, so this is going to be based on the sampling distribution of p hat 1 minus p hat 2. To construct a 1 minus alpha times 100% confidence interval for the difference between two population proportions from independent samples, the following requirements must be satisfied. So these are going to be the same requirements that we had for our hypothesis test. 1. The samples are obtained independently using simple random sampling or a randomized experiment. So in other words, the individuals from sample 1 are not related in any way to the individuals in sample 2. So sample 1 and sample 2 must be independent from each other and random sampling must be used. 2. N1 times p hat 1 times 1 minus p hat 1 must be greater than or equal to 10, and N2 times p hat 2 times 1 minus p hat 2 must be greater than or equal to 10. So both sampling distributions must have large samples so that we have a normal distribution. 3. N1 must be less than or equal to 0.05 times uppercase N1, and N2 must be less than or equal to 0.05 times uppercase N2. The sample size is no more than 5% of the population size, in other words, and that's for both samples. This ensures the independence necessary for a binomial experiment. In other words, what's going on here again is that we have two types of independence again. So we must have independence within each sample, so the individuals in sample 1 aren't related to each other. The individuals in sample 2 aren't related to each other. They're independent from each other. That's the significance of this. And the independence here is that sample 1 is independent from sample 2. So there's two types of independence. Within the sample, there has to be independence, and between the two samples, there has to be independence. And again, we have to have normality. Provided that these requirements are met, a 1 minus alpha times 100% confidence interval for P1 minus P2 is given by the lower bound equals P hat 1 minus P hat 2 minus Z sub alpha over 2 times the square root of P hat 1 times 1 minus P hat 1 over N1 plus P hat 2 times 1 minus P hat 2 over N2. And the upper bound is equal to the same thing, except we have plus instead of minus. So what's happening here is this Z sub alpha over 2, that's the critical value for the 1 minus alpha times 100% confidence interval, just like when we were doing confidence intervals for a single proportion. And then this is the standard deviation of the p hat 1 minus p hat 2 sampling distribution. So in other words, this is the margin of error. So we could say that the margin of error is equal to this Z sub alpha over 2 times the square root of the p hat 1 times 1 minus p hat 1 over N1 plus p hat 2 times 1 minus p hat 2 over N2. That's the margin of error. So we're going to find the difference between the 2 point estimates, and we're going to subtract the margin of error, and we're going to take the difference between the 2 point estimates plus the margin of error. So let's take a look at an example. Body mass index. The body mass index, or BMI, of an individual is a measure used to judge whether an individual is overweight or not. A BMI between 20 and 25 indicates a normal weight. In a survey of 750 men and 750 women, the Gallup organization found that 203 men and 270 women were normal weight. Construct a 90% confidence interval to gauge whether there is a difference in the proportion of men and women who are normal weight. Interpret the interval. So the first thing that we're going to need to do is we're going to need to find the point estimates for both men and for women. So if we look at men, which we're going to call that P hat 1, well, the point estimate there is going to be 203 out of 750. And for women, the point estimate there, which we're going to call P hat 2, is 270 out of 750. Now, 203 divided by 750 is 0.2707 if we round to 4 places. So this is approximately 0.2707. So about 27% of men were normal weight. If we take 270 divided by 750, that is 0.36. So 0.36, so about 36% of the women were normal weight. Now these were from samples. So what we're wanting to do is we're wanting to construct a 90% confidence interval for the differences between the proportion of men and women who are normal weight. So we need to calculate the margin of error. Well, our margin of error is going to equal z sub alpha over 2 times the square root of p hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. So here's our margin of error. So if we calculate that, we're going to need to know the critical value for a 90% confidence interval. So if we think about that, we're dealing with a normal distribution. We're doing a 90% confidence interval, which means the area between the two critical values needs to be 0.90. So if the area in the middle is 0.90, then that means the area in the two tails is 0.10, and half of that is going to be split between each tail. So 0.10 divided by 2 is going to be 0.05. So the area here is 0.05 and the area here is 0.05. I'm going to need to determine those two critical values. Those two critical values will be the same value other than one will be negative and the other will be positive. So how can I determine what those critical values are? Well, we can use either the standard normal table from the textbook, we can use inverse norm on our calculator, or we can use the normal calculator in StatCrunch. I'm going to use inverse norm on the calculator. So if I go to inverse norm, in this case, I have the area in the left tail is going to be 0.05. That is the area in the left tail. And so I get negative 1.645. This value is negative 1.645. So by symmetry, this value over here on the right is positive 1.645. So that is my z sub alpha. Z sub alpha is 1.645. So I'm going to use that here in this formula. And likewise, this is p hat 1, this is p hat 2. So my margin of error is going to be 1.645, again that's my z sub alpha, times the square root of p hat 1, which is 0.2707, times 1 minus that, divided by the sample size, which was 750, plus p hat 2, that's 0.36, times 1 minus 0.36 divided by its sample size, which was also 750. Now in this particular case, both N1 and N2 were the same value, 750, but they would not necessarily have to be the same value. So if I type this into my calculator, that's going to give me the margin of error. So bring in my calculator. I have 1.645 times the square root of 0.2707 times 1 minus 0.2707, close parenthesis, divided by the sample size, which was 750, plus, still underneath that square root, 0.36 times 1 minus 0.36 divided by the sample size, which was also 750, and that's it. So I get a margin of error, if I round to 4 places, of 0.0393. So this margin of error is 0.0393. So now my confidence interval is going to be p hat 1 minus p hat 2 minus this margin of error to p hat 1 minus p hat 2 plus the margin of error. So this is going to be my confidence interval. So next I'm going to figure out what is p hat 1 minus p hat 2. Well, p hat 1 minus p hat 2 is going to be 0.2707 minus 0.36. That is the point estimate for the difference. 0.2707 minus 0.36, that is negative 0.0893. So this is negative 0.0893. So my confidence interval is going to be that point estimate, negative 0.0893, minus the margin of error, 0.0393, to negative 0.0893 plus the margin of error, 0.0393. So negative 0.0893 minus 0.0393, that is negative 0.1286. So this is negative 0.1286 to negative 0.0893 plus 0.0393 is negative 0.05. So negative 0.05, and I'm going to go ahead and say 00 to keep that to 4 places like I have for the lower limit. So we found our confidence interval for the difference between the proportion of men and women who are normal weight. And so we have found that that is between negative 0.1286 and negative 0.0500. So we are 90% confident that the true difference in the proportion of men and women who are normal weight is somewhere between negative 0.1286 and negative 0.0500. So if we were conducting a hypothesis test, notice that that does not contain 0. The fact that this does not contain 0 indicates that there is a difference between the proportion of men and women who are normal weight. And in particular, it looks like the proportion of men who are normal weight is less than the proportion of women who are normal weight because we have a confidence interval that's entirely negative. Now we have done this confidence interval by hand. We could also do this confidence interval on the TI calculator or in StatCrunch, so I want to show you that next. So to construct the confidence interval on my TI calculator, I can bring in my calculator. We're going to go to Stat and Tests, and in this case we're going to be constructing a 2-proportion z-interval, which on my calculator is option B, 2-prop z-int, so 2-proportion z-interval. So I'm going to select that. Now when I select that, I have to enter in the numbers. So for our men, which was X1 and N1, we had 203 successes out of 750. And for women, we had 270 successes out of 750. And our level of confidence is a 90% level of confidence, so the C level is 0.90. So when we calculate that, my confidence interval is negative 0.1286 to negative 0.05, which agrees with what we got by hand. Notice it also gives us the point estimates for p hat 1 and for p hat 2. Similarly, we can do this in StatCrunch. In StatCrunch, we go to Stat and Proportion Stats. We're going to go to To Sample because we're dealing with two samples, and we have summary information as opposed to data. Incidentally, this is the same place where we went to do our hypothesis test for the difference between two population proportions. So for the number of successes for sample 1, we had 203, and the number of observations was 750. For sample 2, we had 270, and the number of observations 750. This time we're doing a confidence interval, and the level of confidence is 0.90. When we say compute, StatCrunch returns the lower limit of negative 0.1286 and an upper limit of negative 0.0500, and that agrees with both our by hand calculations and with the TI calculator calculations.